Alright, so the next application I'm going to look at is whenever we're completing a job and we're going to have two people. We're going to have two people. So this is like a lot of times we'll do painting a room. Right? Suppose I can paint a room in 5 hours. Joe can paint a room in 3 hours. If we work together, how long will it take us? Alright, so these are applications of working together. Students always find, actually, I personally find these applications some of the tougher ones for me. Somehow mentally they're just harder. These applications where we're combining people to work together. Alright, so suppose we're going to do an example of two gardeners. Alright, suppose a lawn can be raked by one gardener in 3 hours and a second gardener in 5 hours. So the one guy's a little faster, he's a little more efficient. The first guy is a little more efficient than the second guy. Alright, but suppose those two gardeners decide to work together, and we want to know how long will it take them to rake a lawn, one lawn together. And so if you think about it, it takes the first guy, alright, so first gardener, 3 hours to complete one job. Right, the job would be raking the lawn. Right, the second gardener takes 5 hours to complete one job. Alright, we want to figure out how long will both take to complete one job. Right, that's what you sort of have to figure out. And so what we're going to do is we're going to break it down per hour. Right, that's what we're going to do is break it down per hour. Right, so I'm going to let T equal the time it takes to rake one lawn, right, to complete one job. That would be my one job, right? Rake one lawn. And so I want to break it down per hour. All right, I'm going to let, how long does it take to complete this amount of time to complete one job, right? How long does it take? Well, if I'm looking at it per hour, in 1 hour, the gardener can complete 1/3 of the job, right? If it takes him 3 hours to complete one job, in 1 hour, gardener 1 completes 1/3 of the job, right? If he could complete one job in 3 hours, he completes 1/3 of it in 1 hour. 1 hour. In 1 hour, gardener 2 will complete well, it takes him 5 hours to complete one job, right, which means in 1 hour he'll complete 1/5 of the job. Right, so in 1 hour, gardener 2 will complete 1/5 of the job. Alright, so my equation involves completing one job. Alright, so one job. It takes the first guy 1/3 of an hour. So if T represents the time it takes to rake the lawn in hours, 1/3 of those hours could be completed by the first guy. 1/5 of those hours will be completed by the second guy, right? Because that's the speed that they can complete the job in, one job. And so this represents the time the first guy takes, because he takes 1/3 of an hour to complete a job. This guy takes 1/5 of an hour to complete a job. Total time in hours would be the speed of the first guy, which is 1/3 times time, plus the speed of the second guy times time, and I add them together and they complete one job, right? So this it equals one job. All right, so my equation I want to solve is 1 equals 1/3 T plus 1/5 T. Find T, all right? T is how long it takes him to complete the job, to rake one lawn. That's what we're looking for, right? And so now I have to solve this. There's a few different ways you can solve it. I think using you can solve it graphically. Graph it, solve it. T would be X if you graphed it in your calculator. But I'm going to use the lowest common denominator. So 3 and 5 again. The lowest common denominator of 3 and 5 is 15, right? 3 goes into 15, 5 goes into 15, 3 times 5 is 15. And so I'm going to multiply both sides by 15. So remember, multiply the entire thing by 15. So this side, 1 gets multiplied by 15. And I'm going to distribute it so that you can see everything gets multiplied. So my 1/3 t times 15 plus my 1/5 t times 15. Which this was the goal. Here, my 1/3, you can take 1/3 times 15, it'll reduce to 5t. My 1/5 times 15 will reduce to 3t. So I've got 5t equals, 5t plus 3t equals 15, and then solve. So 15 equals 8t, divide by 8, and so I've got 8's reduced, so I've got time equals 15 over 8 hours. Alright, so it takes them about 15 divided by 8, and if you divide that out, it'll take them about 8.75 hours to complete the job. So it takes about 1.875 hours, so a little under 2 hours, to complete the job. If you read that, 8.75. And then you kind of look, does your answer reasonable? Right? They should be faster than the one guy doing it alone, right? The one guy can do it alone in 3 hours. He's getting a little bit of help from the second guy. And so it should make sense that it's less than 3 hours. Now, it's pretty close to 3 hours because the one guy's doing it about as fast as he can, and he's getting a little bit of help from the other guy who's much slower. And so around under 2 hours is pretty reasonable in that case. Alright, so again, there's my answer. Alright, so that is an example of combined application of working together. Alright, then the last application involves similar triangles, and I'm just going to go ahead and finish this together on the same video. Alright, so the last application we're going to look at is a geometry type. So this one I am going to draw out the picture because I think it's always good to do that when we can. Alright, suppose we have a 6-foot tall person that stands 15 feet away from the base of a street light. So we've got a street light. If the person's shadow is 10 feet long, estimate how tall the street light might be. Draw the picture in this case before I go and set anything up. So the picture would be, alright, so I've got my street lamp. Alright, this would be my lamp, so this would be the street lamp. Then my guy who is here, so this is 15 feet away. Alright, he's 15 feet away from the base, so this would be my person, which I'm just going to draw a stick figure. Alright, which I know he is 6 feet tall. Alright, and the person casts a shadow, right? So the light shines. Alright, he comes down and he shines on the person, right? This would be the light shining down. And so this distance here would be the person's shadow. Alright, this would be the shadow, which I know is 10 feet. Alright, so this distance from the person to the end of his shadow, right? Because the light is casting it down. We want to know how tall, or estimate, because again it's a guess, just based on the angle. We don't know what the angles are and all that stuff, so we're just basing it on a guess. We want to know how tall the light is. So that's going to be my x value. I want to know how tall is this light pole. Alright, so x is going to represent, or you do h if you prefer height. X is the height of the street lamp in feet. Alright, and what I have here, the reason why I wanted to draw the pictures, because you're going to see there are actually two triangles, and they're similar. Similar because they have, this is a right triangle. This is because the person stands straight up. This is a right triangle. And they share this angle. And so there are two similar triangles. There's the big triangle, and then there's the little triangle. Alright, which actually I'll pull that little triangle off. So then there's that little one that I'm pulling out, right? This is the person's, this triangle piece there. And they are similar. We have similar triangles. myself more space, because apparently I didn't give myself enough space to draw this out. Alright. Hopefully that's enough. Alright, so I've got my similar triangles, and I'm going to write my stuff in. So this would be the street lamp side, so that's x. This total distance would be the total distance here, right? And so the bottom of the similar triangle would be 25 feet. Because it's the 15 feet from the person and the added shadow, which is 10 feet. So that total distance is 25. And then the small triangle, well, the height is the height of the person, so that would be 6. And then this is the shadow part, right? So that's 10 feet, and it's all in feet. And so remember, corresponding sides of similar triangles are equal. The ratio is equal. And so we set it up. The height and the base, so these base heights are similar to those on the other similar triangle. So the ratio of the height over the base, 25, is equal to that same ratio here. Just have to make sure they're in the same spot, right? 6 is in the same spot as x, so this would be 6. 10 is in the same spot as 25. And so because they're similar triangles, the ratios between the legs should be the similar, right? The ratios between the height and the base of both my triangles should be the same. And so that's the equation I solved, right? Because they're similar triangles. And so this one I'm going to use cross multiplication because they're ratios. So I'm going to multiply across. So I'm going to get 10x equals 6 times 25. So take our 25 multiplied by 6, comes out to 150. That gets rid of the fractions, and then divide out by 10. And so x equals 15. And that's just a coincidence. It's just the way the numbers worked out this time. So that's not always going to be the case. It's not always going to be the same as the person's distance. There's a coincidence that this is 15 and matches that 15. Again, that's just a coincidence. So don't think it's always going to come out that way. All right, so the answer, the street lamp, is about, because it is an approximation, 15 feet tall. And that seems reasonable, right? The ratios are the same if you check it. 15 divided by 25 should be the same as 6 over 10, which is 0.6. So if you take your 15 divided by 25, it should come out 0.6, and it does. So this is sort of, it checks. All right, so the lamp is approximately, based on similar triangles, 15 feet tall. Right, so like I said, I hit sort of the 4 big ones. I did a geometry type, similar triangles. I did a working type, where 2 people work together to complete one job. I did a mixture type and a motion type, where we use distance equals rate times time. There are many types, and again, it would take me too long to go through all of them, so make sure you look over the book. The book also has other videos that go over these as well. So if you just want one more time somebody to go over these with you, and maybe in a slightly different way than what I did, it's always good to come at things different ways. You can look at them, so if you go to your multimedia library 2.2, search for videos, it'll show you that there are application video types that they actually go through and work for you. Alright, so do make sure you look at those, make sure you do the homework, and practice these. Alright, so that wraps up 2.2.